Okay, let's take a look at section 6.2, writing and solving proportions. First of all, a proportion is an equation that states that two ratios are equivalent. So we saw yesterday a ratio can be written 3 to 4, 3 to 4 with the actual word, or 3 over 4, which is also a ratio. So there's three different options. We're going to focus on this option, the fraction. And to write two ratios equivalently, that would be something like maybe 2/4 is equal to 5/10. And we can look at it and we say, well, that fraction is 1/2, that fraction is 1/2, so they both must be equal. But really, another word for these being, rather than just saying that they're equivalent fractions as we have in the past, now we're using this word proportion. Proportion just states, it's an equation because there's an equal sign, and it states that two ratios, we have two ratios, are equivalent. So here's a number example. If we were to type it, work it out with a algebraic example, it might look something like A over B equals C over D. And then we would obviously have to say that B and D don't equal 0 because we can't have 0 in the denominator. Okay, now oftentimes whenever we see proportions, they're going to have something like this, a missing piece. So there's three different ways we're going to learn how to solve them. The first way is with basically mental math. We're going to think of this is the equivalent ratios method. If you happen to see that in your textbook somewhere, it says use equivalent ratios, this is what they mean. So here you're going to say, all right, 7 times what gives me 21? What do I multiply this denominator by? I multiply by 3. So then if I do the same thing in my numerator, I get my answer, x equals 6. And I can just mentally see that. So here, 8 times 4 is 32, so 3 times 4, x equals 12. No real calculations involved other than recognizing those points. Here I could say 2 times 5 is 10, so what times 5 is 20? Or I could work the other way as I could up here, and I could say, all right, x is on that side, so I'm going to have to go in that direction, from here to there. So in the denominator I went 10 divided by 5 equals 2, so in the numerator 20 divided by 5, x must be 4. And then in letter D, same kind of concept. Since my x is here on the left, I'm going to be going in that direction. So 12 times what equals 48 times 4. So 6 times 4, x is 24. Okay, so that's the first way of thinking about them. Another way of doing it is using algebra. And we're only going to cover two of them today. Tomorrow we'll do the third method, or in the next lesson rather. Using algebra brings in what we did last chapter where we have reciprocals. So this 12 is in the denominator. If I want to get that 12 out of the denominator, then I'm going to multiply by 12 over 1, which is the reciprocal. And I'm going to do that on both sides. My 12s cancel, x comes down. And over here I just have a multiplication problem. I can do a little bit of canceling, 3 and 2. And then 2 times 3 is 6, 2 times 1 is 2, and my final answer simplifies to just be 3. And that's it. Letter B, I can say, all right, multiply by the reciprocal, which would be 98 over 1, 98 over 1. Okay? And then here, I can check and see. We are allowed to use calculators in this chapter. So I can see if 7 does go into 98, and it does. It goes in 14 times. 3 times 14 is 42. Just double checking. And that's our answer there. And obviously, if we wanted to check this, you can always do something like this. Put your answer back in for x. 42 over 98. Put it in your calculator. See what the decimal is. You're going to get, it's a long one, 0.42857, on and on and on. But then if you check 3 over 7, the other ratio, and you divide those, you're going to get the same thing, 0.24, da 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 da. So both of those work. Okay, let's look down at the U-try. We'll kind of work through these ones real fast. I'm going to multiply by the reciprocal, 30 over 1, 30 over 1. Oh, that looks like not a 30. My 30s cancel, x comes down. And here I look to see if anything will cancel. I can divide both by 4, or I'm sorry, both by 2. I get 4 and 15. 15 times 3 is 45, and that's my answer. In letter B, multiply by the reciprocal, which would be 9 over 1. Let's clear that part I just did. Okay, multiply by the reciprocal, and the reciprocal is going to be whatever is with the x. So I want to get that 9 out of the denominator, so I multiply by 9 over 1. 3 goes into both 9 and into 6. So I multiply straight across. I get 15 over 2, which is the same as 7.5. Either one is fine. Here I'm going to multiply by 15 over 1, 15 over 1. My 15's cancel and x comes down, and that's my goal. But then here I can say, all right, 3 goes into both of these. 3 goes into 15 5 times, into 24 8 times. 11 times 5 is 55. 8 times 1 is 8. And then I can simplify, turn into a mixed number, put it as a decimal, however it is that you're asked to finalize it. All right, now let's take a look at this next page. Just a few quick word problems. Consider the following. Yesterday you rode your bike 18 miles in 2.5 hours. Today you plan to ride for 3.5 hours. And if you ride at the same rate as yesterday, how far will you ride? All right, so they're giving us this rate, 18 miles in 2.5 hours. So let's write that out. 18 miles, 2.5 hours. Now today you plan to ride for 3.5 hours, 3.5 hours, and it's saying if you ride at that same rate, which is right here, as you did yesterday, how far will you ride? So they want to know how far are we going to go. Well, 3.5 hours. So that's going to go in the denominator because we put 2.5 hours in the denominator before. You have to keep the units the same correspondingly. And that we're going to try to solve. So really what our proportion is, getting rid of the units, is 18 over 2.5 equals x over 3.5. I'm going to multiply by the reciprocal, 3.5, essentially 3.5 over 1, 3.5 over 1. My 3.5's cancel and x comes down, and over here I can pull out my calculator. Now I have a couple options. I don't have to do the cross-canceling because I'm using calculators, and there's decimals, so that's a little bit much. But what I can do is just multiply either straight across, and then divide, or I could simplify this and multiply together. Since we've been doing multiplying fractions, I'm just going to multiply straight across. 3.5 times 18 gives me 63. 1 times 2.5 is 2.5. And then I'm going to divide the 2 to get my final answer. And my answer is x equals 25.2, and I want to label it miles. That's how much I would cover if I went at that same speed, the same rate I did yesterday. All right, let's try example 3 with the elephant. Each day an elephant eats 5 pounds of food for every 100 pounds of its body weight. Use this information to write and solve a proportion to determine how much food an elephant that weighs 9,300 pounds eats per day. So break it up. They're telling us, 5 pounds of food for every 100 pounds body weight. That's the key there. That's one of them. So let's write it out. 5 pounds food for every 100 pounds. I'm just going to abbreviate BW, body weight. And then they say use this information to write and solve a proportion. So we're going to have that equal sign and then another ratio to determine how much food an elephant weighing 9,300 pounds is going to eat. So that's its body weight. So that's going to go in the denominator, 9,300 pounds of body weight. And they want to know how much food is it going to have to eat. So I'm going to write this down here to actually solve it for more space. But really I have 5 over 100 equals x over 9,300. Now some people say, can I simplify this? And yes, you definitely can. If you want to simplify and write 1/20th, that's fine. If you don't recognize that, don't want to do it, you don't have to. I could look and say, all right, well 100 times 93 is going to give me 9,300, so 5 times 93, and I'm going to get my answer right away. It's 465, but maybe you didn't see that, so we could do the reciprocal method as well. The nice thing here is that there's a lot of options to get the answer, and they all give you the same answer if you do them right. All right, my zeros cancel. 93 times 5 is 465, and I have to label it pounds of food if it weighed that much, okay? And this next one is the same situation, only instead of there being 9,300 pounds, it's 12,500 pounds. Great job, guys.